do the intro. All right, so my name is Lee. I'm a communicator here at the Kennedy Space Center. I'm one of the faces of NASA telling our story of space life. Now, the story today is going to be about something called the space race. And in the process of telling that story, we're going to learn about the cool rockets we have here in the rocket garden. All right, so if you follow me, let's go on in. Now, the most common question we get here in our rocket garden is, are these rockets real?
Yes.
Dramatic pause.
Yes, they're real because they're
Yes,
right there.
these are absolutely real. Now, we do have one exception, and that is this Atlas rocket right over here. This is a replica. But we have one just like it that's absolutely real over here, which says 553, a silver rocket right there. That is a real Atlas rocket. Now, if you compare the two, you can see the real one has more detail. There's rivets, more things in the mechanisms, and things like that, whereas the replica is a lot simpler. And that gives you an idea. You can tell what a real rocket looks like versus a replica. All right, our story begins on October 4th, 1957. The Soviet Union launched the world's first artificial satellite around the Earth. Didn't do much. Sorry. Didn't do much. It just went. Anybody happen to know what the name of that satellite was? Yes. Sputnik, that is right. Very good. Now, this was a bit of a surprise because we didn't yet know that the Soviet Union had orbital-class rockets. We were still working on our own, hadn't had a chance to figure out how to do that yet. And so it took a few months, but we eventually got our own artificial satellite up into orbit. And that was called Explorer 1. Now the rocket we used right behind you over there, it says DE. The cylinder there, that's actually upper stage. The payload is that tiny little white pencil-shaped object on the top. And this is a Juno 1 rocket. It was based on the Redstone technology, which was, again, based on the German V2 technology, because we were lucky enough to inherit some German rocket scientists after World War II. Now, we launched this Explorer 1, and we decided to not make it deep, but to perform some science. So we put instruments on there, including Geiger counters to check for radiation. And when we ordered on a pilot, and we discovered there were bands of radiation trapped inside the Earth's magnetic field. They were later called the Van Allen bells, after Dr. James Van Allen, who had predicted they would be there. Now, after that, in the summer of 1958, that was like in January 58, by the time we got into the summer, the president of the time was Dwight D. Eisenhower. And he served in the military as a general during World War II, and he understood the strategy of something called taking the high ground. Well, space, it turns out, is the ultimate high ground. Now, he also wanted to make sure our efforts were done by a civilian organization as opposed to the military group that was being used by the Soviet Union. So in the summer of 1957, by an act of Congress, NASA was created. Now, it became operational in October of that same year. Does anybody here happen to know what NASA means? It is not a word, it's an acronym. Each letter stands for something. Anybody know?
Space.
You got the first one right. National Aeronautics
Space
Space Administration. Very good. That's a team effort. Very good, guys. Pat yourselves on the back. All right. So, and that shows that NASA also does research into aeronautics to make air travel safer as well as more fuel efficient. All right. Now, once NASA became operational in October of 1958, they launched the first NASA-branded rocket. It looks like this one right over here with the all-white rocket with the NASA on the side. This is before NASA put logos, or their logo, on rockets. And this was a deep space probe. This is also based on a Juno rocket. This is called a Juno 2. And it launched a deep space probe called Pioneer 4. So anything beyond low Earth orbit, at least for now, is considered deep space. So we did that to do a flyby of the moon. We got about 30,000 miles away from it, and it helped us learn more about the moon's surface as well as the space between the Earth and the moon called cislunar space. Now, also during this time, we discovered that we could use rocket technology to make our lives better here on Earth. So, the one we used for that, or one of the ones we used for that, is this funny looking rocket with the 19 on it right there. So it's kind of skinny there, and got a blue on top. That is the Delta Thor rocket. So the first thing is called Thor, and normally all of these rockets that we were based on were military missiles. So we repurposed them for doing some commercial work. And so the second stage is called Delta. The top part is where the satellites were under that kind of bowl-shaped barrier. The barriers are used to protect the payload until they get into space, so they don't have to be aerodynamic. So we launched things like our first telecommunications satellite called Telstar 1, and our first weather satellite called Kuro 1. Now, since then, we've launched dozens of these types of satellites, and we use them every day to make our lives better here on Earth. Now, during this time frame, the Soviet Union was on standing still. And on April 12, 1961, they did something else that surprised us. They put the first human into orbit around the planet. Does anybody have to know what that guy's name was? Yuri Gagarin. Very good. We got some smart people over here. Thank you, sir. Now, Doc, did you say Doc? Doc's too long there. Okay. So, this is something we were not ready to follow, at least not right away. It took another almost a year before we were able to put the human into orbit. But we could do the next best thing. So on May 5th, a few weeks after the Gagarin flight, we launched an astronaut into space on a suborbital flight. So they didn't get into orbit, but they got into space. Now space is considered anything over 100 kilometers or about 62 miles above the Earth. That's the worldwide or the European standard. The American standard is 50 miles. But the person on this flight more than doubled the Kármán line, and that's the 100-kilometer line. So the astronaut we picked to do that, it was the beginning of the Mercury program. His name was Alan Shepard. So we put him on top of one of those Mercury capsules. This is the actual size right here. You can see how small it is. Tiny little tin can for one smaller than average human male. You could not be tall to be an astronaut during the Mercury program. Because the taller you were, the more you weighed, and every pound counted. So Alan Shepard was put into one of those Mercury capsules we launched from here in Florida. The launch vehicle was called the Redstone, which is a direct descendant of the B-2 rocket used during World War II. Now, this was a suborbital flight, and it only lasted 15 minutes and 22 seconds. So we launched from here in Florida, went over the Atlantic Ocean, and Alan Shepard splashed down in the Atlantic just north of the Bahamas. That's the best we could do a few weeks after the Yuri Gagarin flight. Now later that same month, the new president, John Fitzgerald Kennedy, for whom this facility is named, had a vice president by the name of Lyndon Baines Johnson from Texas. And Johnson was Kennedy's space advisor. So he did all the briefings he learned, all that he could learn, took tours of our facilities. He went back to Washington and briefed Kennedy on what our capabilities were. Later that same month, on May 25th, 1961, Kennedy then delivered a speech to a joint session of Congress. And in that speech, he said the following statement: I believe this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. That was John F. Kennedy. That's not good news. Anyway, this is a surprise to most Americans because we had no clue what our capabilities were. We had one flight, 15 minutes in space. And now we're going to go all the way to the moon? But Congress wrote NASA a blank check. Spend whatever you need to figure out how to get to the moon before the end of the 1960s. That was the birth of the Apollo program. Now, the flight plan for Apollo was not what you might think. There were three possible options. One was what we call a direct descent. You build a really big rocket, twice the size of the Saturn V, to go directly to the moon, to land a pretty good sized spacecraft on the moon, and that spacecraft would actually come back. This turned out to be too much for what we could accomplish in the 1960s. There was another version that used two Saturn V type rockets, putting together a spacecraft in space that would then go to the moon. We settled on something called lunar orbit rendezvous docking. So that is where we sent a launch vehicle the size of the Saturn V, and we just kind of threw pieces away as we went. And when we got to the moon, there were two different spacecraft. One stayed in orbit around the moon, the other was the lunar module that landed on the moon, and later it would be the upper part that would got back to Earth, the only part that made it back intact was the tiny little command module with the 3 astronauts inside. So that's how we did it. That's how we
After this
designed
clue,
this
okay?
mission to the moon.
5 more minutes.
Now, no one had ever done rendezvous in orbit, especially around the moon. So we had to learn that technology of doing rendezvous and docking. Now, to do that, Apollo wasn't ready yet. They're still on the drawing board. So we used a larger version of the Mercury capsule called Gemini. You can see it right on top of this rocket right here. This is a Titan II ballistic missile. It's a 2-stage ICBM. We were still using military rockets to get our astronauts in space. So they strapped a couple of astronauts on the top of this ICBM and launched it into space. Now, sometimes we launched 2 Gemini capsules and they were supposed to find each other, rendezvous, but they could not dock. The spacecraft were not designed for that. So if they wanted to practice docking, they had to use a target. So we used one of our Atlas rockets, you see right here, to launch first the Agena capsule that's on top, the second stage. That would be in orbit, then they would then launch a Gemini rocket, the Titan II with the Gemini capsule on top. They would go find Agena and dock with it in space.
Yeah.
Now sometimes that would mean 2 launches in one day. Early in the day they would launch Agena, and then later they would launch Gemini with 2 astronauts on it. Now the last one of that was 1966.
No, I only have 2 hands.
We rarely launch more than 1 astronaut in any given day. But it happened
Stop it.
in 2022 and in 2023
Put it on the
twice.
ground. I
As
can't
a
put
matter of
it.
fact, the most recent one was a Falcon Heavy launch, followed by a Falcon 9 launch about 3 hours later. That broke the record, having launches that close together. All right, now, after 12 missions on Gemini, we figured out what it would take to do rendezvous and docking. I do want to back up just a minute and tell you about the Atlas rocket that we used. Finally, in 1962, we were able to get a human into orbit. Anybody know who that name was? He later, oh, that's a good guess, but no. He later became a U.S. Senator and went back to space at the age of 77 on the space station. He's from Ohio. John Glenn, very good, very good. So it took quite a while. Now he did 3 orbits and did something called the applesauce experiment to show people could eat in orbit. Alright, so now we're waiting for going to the moon. So we're going to go off to the other side of the rocket garden here, and we're going to look at some of that technology we use to get to the moon.
Albert, get your drink.
So during all this time, we were still behind in the space race. Every time the Soviet Union launched something, they broke a record of one kind or another. And so we were getting pretty frustrated. But with Apollo, that was the hopes that we had of finally getting ahead of the Soviet. All right, so we're going to get a little closer over here. I got to stay within line of sight of those antennas. All right, so you see this white rocket right on the side over here. That is not a Saturn V. That is something called the Saturn 1B. So this was designed to take the Apollo spacecraft just to lower orbit, not to the moon. Now you see, it's a pretty good-sized rocket here. You got these cylinders kind of strapped together. They were based on Redstone rockets that they put together to be able to deliver what kind of rocket 8 engines on it. Then the second stage says USA right there in red. And then beyond that, where that black line is, beyond that, were the Apollo spacecraft. So we had something called the command and service module. That was on the end of the rocket. Now that little rocket you see on the top, that was called the launch escape tower. And that was used in case something went wrong up until the second stage of the car. So once they get into space, that was wrong. Now the cone-shaped white area you see right there, that's what the module folded up the legs and they stuck it in there to practice rendezvous and docking around the Earth. Now before the lunar module was ready, we felt pressure because we had intelligence, supposedly, that the Soviet Union was going to launch a lunar rocket very soon. Turns out that rocket called the N-1 had a nasty habit of blowing up every time they launched in space. So to this day, the Soviet Union and later Russia have never sent cosmonauts beyond low orbit. So the first mission to go out to the moon was Apollo 8, and that's when we used the Saturn V. So the idea was to go out to the moon over 10 times and come back. Now the Saturn V is a lot more powerful than the Saturn V. Now, to give you an idea how much so, you see this rocket engine right here, this gigantic rocket engine? This is called the F1. Now, this is, to this day, is still the most powerful liquid fuel single chamber engine ever flying into space, actually in the orbit. Now, to give you an idea of the power, this one F1 engine here is almost as powerful as the entire first stage of the Saturn 1B. And we had 5 of them at the base of the Saturn 5. So to give you an idea of the size, you take the Saturn 1B here, add another 50% to it, and that's the height of the Saturn 5, about the height of a 36-story building. So Apollo 8, on December 1968, we sent 3 astronauts, Chip Lovell, and Bill Andrews, to go out and come back. Now this mission put us ahead of the Soviet Union in the space race because they never got past World War I. Here we are, now on the fourth pass.
Daddy, where's mommy?
They were not going to get over it a little bit. All right, can you hear me now? Can you hear me now? All right. So, that's my Verizon commercial. Anybody remember those little Verizon commercials? They're walking around, can you hear me now? Can you hear me now? And sometimes it feels like that, because this PA says it's a little bit tricky. Now, on the fourth orbit, they saw something come out over the lunar horizon they were not prepared for. They knew it was going to happen sooner or later. They were not prepared for how magnificent it was. They saw the Earth coming up over the lunar horizon. Quickly, we took some pictures of that. Those images became known as Earthrise. And the reason why they were so surprised is the Earth was luminescent. It glowed. And it showed how fragile a blue planet was in the vastness of the cosmos. Many people think that that was the beginning of the modern environmental movement.
Now after Apollo
8. So the next time that we went to land on the moon was Apollo 11. All right, now that happened on July 20th, 1969. Is anybody here that actually remember the moon on July 20th, 1969? Anybody here as old as me?
you're my
People. All right. Sorry about the audio here. It's a little bit worse than normal. I'm going to move up here a little bit. You're my people. Because I was 9 years old when we landed on the moon. And I have been a big fan of the space program ever since. It's probably why I'm out here doing this rocket garden tour, because space is my passion. All right, now, we landed. 2 people were working on the moon. The 3rd person stayed in orbit in the command module. So I'm going to ask you, the kids here, they're under the age of 18, the question. Who was the first person to walk on the moon? Raise your hand, let me know. I'll say your name first. Neil Armstrong, very good. Right, I'm going to do Armstrong. Pays to be smart around here. All right, question number 2. Who was the second person to walk on the moon? Yes. Alex Shepard? No, he was on Apollo 14. All right? Second person to walk on the moon was on Apollo 11. Anybody? Any kids here? Yeah. Buzz Aldrin, that's right now. I only know one professor. All right, let's give him a round of applause for being so smart. That's pretty cool. All right, now, this next one, I'm thinking about everybody because this is a long-term question. There was a 3rd person on Apollo 11 who did not get to walk on the moon. He was in the command module pilot. He stayed in orbit around the moon. You know who that was? Yes. No, that's Apollo 14.
Oh, shoot.
Alex Shepard got to walk on the moon. Yes. Oh my God! All right, I'm going to give you something else. All right. I'm from Apollo 11 point.
kids almost never know that.
There you go. That's Apollo 11 point.
Yes, you make that a rule. Okay? You deserve that extra point.
All right, that's so cool. I see great things. Now, after we landed on the Apollo 11, we came, landed on the moon 5 more times for a total of 6 landings. Was that the end of the space race? No, it was not. It wasn't even the end of Apollo. We had world missions right. So, in 1975, well, actually, between 73 and 74, we launched America's first space station called Skylab on Saturn V. And then we sent 3 missions on Saturn 1B. The last Apollo mission at the end of the space race was in 1975, called the Apollo Soyuz Test Project. We sent 3 astronauts up on Saturn 1B. The Soviet Union sent 2 cosmonauts on a Soyuz spacecraft. We docked together in space, opened the hatches, shook hands, and that was the end of the space race. Because it ushered in an era of cooperation between the United States, Soviet Union, and later Russia. We are still cooperating today, there's nothing a little frosty, but we are still working together on the operation of the International Space Station. Now, I've got one last one to show you, the most recent one over here. There's that teal-colored rocket, see there, if you way up there, that's a United Launch Alliance rocket. This is from the Delta II. Now, this has been intended in use for several decades. It was a workhorse rocket back in the day to launch satellites that made our lives better here on Earth. One of those was the first GPS, global positioning system, that we roll around every day to find our way around the Earth. Also, some of the first rovers to land on Mars were launched by the Delta II. And that was pretty cool. Now, we use rockets like this even today to make our lives better here on Earth. Now, I do have one more rocket to show you. It's this cone-shaped green rocket right over here. This is called the Christmas tree rocket, and it won't be here for a few more days, so you get a chance to see that. Isn't that a nice rocket? It's a fly, but it looks pretty. Alright, so thanks so much for joining me on this tour. I hope you'll learn some cool new stuff and have fun doing it. Enjoy the rest of your time here at the Kennedy Space Center. Thank you.